All right, so welcome to the video lecture series on Introduction to Computer Networks, and today's topic is going to be the network layer in the TCP/IP model. So let's just have a quick recap of the different models. First, we have the OSI networking model, which has 7 layers, starting from the lowest layer, that is layer 1, physical, and then we have data link, network, transport, session, presentation, application layer. The first version of TCP has 4 layers, the link layer, internet layer, transport, and application layer. And as you can see, the TCP IP model and the OSI model have corresponding comparisons being placed side by side. And on the far right, we have the newer version of TCP/IP, where the link layer from the previous version is broken down into 2 layers, the data link and the physical layer, and the rest of the layers are the same. So today we are going to look at the responsibilities and the functions performed by the network layer, that is layer 3 in the TCP/IP model and also layer 3 in the OSI model. So the network layer is responsible for ensuring end-to-end delivery. And what we mean by end-to-end delivery is that when a message is intended to be sent from a source to the destination, the two ends are the source and the destination nodes, irrespective of whatever it goes through in the middle. And it's very similar to how you would address a letter to your home. Let's say it's 123 St. John's Avenue in Ohio, and someone from, let's say, Kentucky would like to send you a letter. So the sender just puts in your address, and the postal service takes care of the routing of that letter until it reaches your address, right? That is something very similar to what the network layer does for you. In the network layer, the addressing is based on what we call IP addresses, and they are addresses which uniquely identify a host or destination which is a part of a network, right? And the reason why we call these logical addresses is because the IP address that is assigned to a specific interface of a network node is based on the node's current point of attachment in the network. So let's say you have your mobile phone connected to the campus network. So the wireless interface of your mobile phone will have an IP address allocated from the campus network. Then again, when you go back home and connect to the wireless network at home, the wireless interface on your mobile phone gets a new IP address. This is something different that we saw in the link layer, which works with MAC addresses, and MAC addresses are fixed for every specific network interface. So the MAC address does not change. However, the IP addresses are logical addresses, and they change based on the current point of attachment of a given device to the network. So what the network layer does is that it guarantees and ensures end-to-end delivery of data across the network and a network of networks. And it deals with the routing and the path determination of the data from the source to the final destination. So there could be multiple paths the packet could take, and multiple devices through which it will be traveling through, and the network layer enables that end-to-end delivery. So let's try to look at the basic format of IP addresses. So these are logical numbers assigned to a network device, and they allow devices to be distinguished from its neighbor within the same network. And they can change based on where they're connected in the network, and therefore hence they're called logical addresses. The forms of IP addresses, the most common format that we see in use is called the IP version 4 or IPv4, and this is a 32-bit binary number. According to general conventions, we convert it into 4 octets. So every 8-bit we convert into a decimal and represent it like this. And this is the format of an IPv4 address. On the other hand, we have a newer version, IPv6, which is supported by most addresses, but it's a bit complex in nature. So it is not manually handled the way that we can handle IPv4, and these are 128-bit binary numbers, and as you can see, these are in hexadecimal notations. For the purpose of this course, we'll be more interested with the IPv4 addressing, which are 32-bit numbers and represented in octets, and there are a total of 4 octets to represent the IPv4 address. And there's another thing that is IP addresses can not only distinguish or identify a device, it can also be used to identify groups, which means that it can have a set of IP addresses that represent a collection of devices within a specific small network. And in that case, this group of IP addresses is identified by something that we refer to as the network IP address. So we have host IP addresses, which are individual numbers allocated to specific hosts on the network. And on the other hand, we have network IP addresses, which refers to a group of IP addresses. So the network layer deals with the protocol data unit that we refer to as a packet. So the upper layer in the network in the network stack is the transport layer. So we have the transport layer protocol data unit come here as the data, and then the network layer attaches the header to the transport layer PDU, and together you have the network layer packet. And this is the packet which is then passed down to the data link layer, which then attaches the header and the trailer to create the data link frame. So the primary duties performed by the network layer is addressing, primarily using IP addresses, and it allows us to identify devices so that we can allow communication across a network of networks on a packet-to-packet basis. So that means that the network layer divides the data into packets, and then these packets are routed across a complex network from the source to the destination. The network layer is also responsible for packetizing, which means that it encapsulates the data into packets from the upper layer protocols, which is the transport layer. The network layer also performs routing. That means that there are specific routing protocols which are placed in the network layer so that it can identify the optimal route at a given time for the packet to be sent from the source to the destination. And in the receiver's end, the network layer is also responsible for fragmenting, which means that when it receives a frame from the data link layer, it will extract the data from the packet, and then it actually creates it de-encapsulates the packet so that it can be passed down to the upper layer. So let's try to understand how the network layer functions in the process of a packet being transferred from the source to destination. So we have a source trying to send a message to the destination with two different IP addresses, and the packet will be routed through a network of networks. So let's say the source is connected to D1, which is a part of the complex network that we have, and the destination is connected to D7, which is on the other end of the complex network that we have. So first, the message is created where we have the source IP as 152.16.2 and 2, which is the source IP address, and the destination IP address as 182.18.2 and 2. The packet is sent to D1 from D1 to D2, and as you can see, the source and destination IPs remain the same in the message. So D1 checks whether the message is intended for him and then forwards it to D2 based on the decision received from the routing protocol in the network layer. So the routing protocol next tells D2 that forward the message to D4 because that is the best route to send the message to the final destination IP address 182.18.2 and 2. So D2 sends the message to D4. Then D4 checks if the destination IP belongs to his own IP address. It doesn't, so it tries to obtain the best route to forward the message and forwards it to D7. D7 checks and verifies that the message is not for him, but however, it identifies that the destination address is actually a part of its own one of its own local connections. So that means that the destination is directly connected to D7. So D7 then forwards it to the final destination, and the final destination receives the message and knows, looking at the destination IP, that this message was intended for this particular network host. So if we try to combine the ideas that we have so far gathered from the data link layer and the network layer, so let's say we have a source, in the middle a router, and on the other end a destination. The source has one interface with an IP address and a MAC address for interface 1. The router has two interfaces, 1 and 2, and there are two IP addresses for these two interfaces and also two MAC addresses for these two interfaces. And finally, we have a destination which has only one interface, so there is an IP address allocated to it and a physical MAC address allocated to it. So if a message is intended to be sent from the source to the destination, the end-to-end path or the end-to-end transmission is the responsibility of the network layer. On the other hand, the direct transfer is the responsibility of the data link layer. So if you look at the way the message actually looks like, it specifies the source IP address and the destination IP address, which refers to 10.0.0.1, which is the interface 1 of the source, and also the destination IP address 192.0.0.1, which is the IP address of interface 1 for the destination. However, the source and the destination MAC address is specified according to the data link layer and the direct connection. So the source MAC is the MAC address of interface 1 of the source, and the destination MAC is the MAC address of interface 1 of the router. So next, when the message is sent from the source to the router then needs to send it onward to the destination. And in this case, the directly connected interfaces are interface 2 on the router and interface 1 on the destination. And this is the data link layer's responsibility. So if we look at how the message looks like now, the source and the destination IPs didn't change. So the source IP is still the IP address of the source, and the destination IP is still the IP address of the destination, or the final destination. However, the source MAC and the destination MAC has changed in this case. So the source MAC is now the MAC address of interface 2 of the router. And the destination MAC now is the MAC address of interface 1 of the destination. So eventually, the message reaches the destination through a combined effort of the network layer and the data link layer. The network layer guarantees the end-to-end delivery of the message from the source to the destination, where the data link layer is responsible for the transfer of direct connections between the source and the router, and then from the router to the destination.